Hey guys, I'm Exodia. Now, the part 1 on our simulator game tutorial series didn't really get the response I would have liked, so in this video we're actually going to be doing something different rather than continuing that, as well as also I haven't really had an idea of what I've wanted to do recently, and also a bit of laziness has caused a lack of uploads on the channel, so I'm very sorry about that. However, today, as per request on a comment, I believe on the simulator part 1 video, somebody requested I make a game like Booga Booga. Now, I've never played that game personally, but from what I've seen and heard, it is a pretty good game. And it's like your standard survival game. You spawn on an island and you have to collect like wood from a tree, get food, and you could build a base, and there could sometimes be PvP, and it's like a nice fun survival experience. So I wanted to show you guys how to make that yourself because I thought it would be a really fun idea. So this is going to be part 1 in that series, and just like with the simulator series, if there's like some good feedback, like maybe if we get 25 likes, I know that's a bit ambitious for the numbers I see in this channel. In fact, maybe let's do like 10, 15 likes on the video. I'll continue the series, do a part 2. Otherwise, I'll look at what to post next in the channel in the next week. So yeah, this is going to be part 1 of making a survival game or a game like Booga Booga. And today we'll be setting up the inventory. So to make an inventory, we'll just set up a simple GUI. So I will do that, and I'll be back when I finish it. Okay, so I made a simple little inventory GUI. We got a button that we can click on to open up our inventory. Then we've got 3 materials that we can keep track of: wood, stone, and metal. And I have basically the labels saying which one it is, and then I have a count right below it, and they're all about in the middle of it. You could size it, shape it however you want. So basically what we'll do now is put a local script inside of the GUI that we made, and we'll call it inventory underscore client. And so we'll get a variable for both the button, so local inventory inventory button, equals script.parent, find first child, inventory button. And then we'll do the same thing for the inventory menu. So inventory menu equals script.parent, find first child, inventory frame. Yeah, we'll just call it menu. And so what we'll do is make a local open variable, and this will keep track of whether the menu is open or not, and we'll set this equal to false. So inventory button dot mouse button one click connect function. So what we'll do here is check if open equals false, then we'll set inventory menu. We can either do we can do 2 things. We could either tween it or just set the visibility. I'm just gonna set the visibility. So what we'll do is real quick set this visibility off. So inventory menu dot visible equals true. Open equals true. Else if open equals true, then inventory menu dot visible equals false, and then we'll set open equal to false. So now if we want to test that, then we'll click our button. As you can see, our menu will turn on, it'll open and close freely. And so now what we could do is check to make sure we also, actually before we move on, we need to make some leader stats. Now what leader stats does is, like I described in the simulator part 1 video, if you watched it, it's those stats that appear in the top right of your game, you know, with like the player list and all that. So we're going to make a server in server script service, and we're going to call this stats. In fact, we'll call it player stats. So we'll do game dot players dot player added connect function player. And so what we're going to do beforehand is we're actually going to make a dictionary, which is a table which we can use to store information in this case. So we're going to do local inventory data equals open close curly brackets. So we're going to press enter and drop the line. And then we're going to do open close brackets with some quotations. And then we're going to do wood. And we're going to set this equal to 0, semicolon, or you could do a comma. Then we'll do the same thing with stone. Set that equal to 0. And then the same thing with metal. And we'll set that equal to 0. Basically what we've done is we've just made kind of like a little little table just for our data. This is going to be all the materials we want to store. And so local leader stats equals instance.new folder. Okay, and leader stats.name will be equal to leader stats. It must be called leader stats in all lowercase, otherwise it will not appear up there. In fact, actually, no, we're not going to call that. We're actually going to call it inventory. We don't need to display it because we have our inventory menu to display it. So, my bad. Inventory.parent equals player. So now we're going to make local wood equals instance.new, and we're going to make it an int value because we only want a full whole number. And so we're going to set wood.name equal to wood.parent equal to inventory. We're going to set wood.value equal to inventory data wood. Now, why we have this inventory data table right now is not going to be as important. However, in the future, we will make a data store so that every time the player leaves, they will save the amount of materials they have. So we're going to do that later on. That way, that's why we have this table. It'll be important for that. So local stone equals instance.new int value. In fact, we just copy and paste everything from wood, just change the name. So stone, and then we'll instead do .stone. So now what we could do here is if we want to set a custom value to start out with, we could do that here because it'll set our wood and stone.value to the value inside this table. And then we'll do the same thing for metal. So now if we want to go and test, go to our player, and then we see our inventory folder. We have the values there. Now, if we want to set these to different values, we can do so. And in game, we should have those values corresponding. So, yep, 2 for stone, 1 for wood, 3 for metal. So that does work. We'll just set this back to 0. Whoops. And then the last thing I'm going to do is just design some like small little models that we can use just so we have a way to collect the resource. So I'm going to do that real quick, and then I will get back and return after doing that. Okay, so I made these 3 little simple models, one for a log type thing, some stone, and a bar of metal. Then I put a click detector in each of them. This will set the primary parts to something to use. And then also put a server script inside of the click detectors. And now what we're going to do is make it to where every time we click on the part, resources. And now this could be subject to change in the future, but for now we'll just do that as it's simple and it works. So we'll do local click detector equals script.parent, and then click detector dot mouse click connect function player, because with the click detector, the first parameter that always gets passed, or the only parameter to get passed, and the mouse click function is the player who clicks on the click detector. It'll do player dot inventory. Player dot inventory dot wood dot value plus equals 1. Then we can copy this and paste it into our stone script, except change this value to stone. Then copy and paste this into the metal one and change that to metal. And then also, what we'll do is get the model, so local wood equals script dot, script dot parent, and we'll do wood destroy. And we'll also do a local debounce, so that maybe the part doesn't, or maybe the object doesn't instantly get destroyed if debounce equals false. Like, we're just doing this so we have a check, so it can't be abused, like if you have like an auto clicker or something for whatever reason. So that way you can't get 2 wood per click on the object. This will ensure that we can only get 1 wood with the delay. We'll actually copy and paste this again just to make sure. So we'll do this in the stone and call that stone instead. I'll then do the same thing in metal. And now what we can do is play. And click on each of these objects. So we'll check our resource count first. We have 0 of each, looks like. But if we click on the wood, then we now have 1 wood. Click on the stone, we have 1 stone. And then we click on the metal, we have 1 metal. So now we'll make it to where this value will update with these text labels to show how much wood, stone, and metal we have. As well as we'll make it where we right click on each of those labels, then we will eject a piece of the material out and also lose one. So what we can do is go back into our inventory client and do, we'll get a variable for each of those. So local wood count equals inventory menu dot wood count. Local stone count equals inventory menu dot stone count. And then local metal count equals inventory menu dot metal count. And so we'll set wood count dot text equal to player dot inventory. Right, we need to get a variable for the player. So local player equals game dot players dot local player. That's my bad. So player dot inventory dot wood dot value, and then player dot inventory dot wood colon get property changed signal colon connect, or actually value. Then we do colon connect function. Then we can copy and paste this, and then copy and paste that, and then fill it with stone. Then do the same with metal. So now we can check to make sure that our inventory is going to update. So we'll just look at this, and then boom, we collect the materials. And so now we will make it to where when we right click on the label, we will, let's see, let's do, I know what I can do. So we're gonna go into our client. Actually, wait, we're gonna insert a remote event first because we're gonna need to get a server script for our inventory. So I'll call this drop object. And then we'll go into server script service and make an inventory. So inventory underscore server. And so local replicated storage equals game get service replicated storage. Local drop event equals replicated storage. Dot or colon find first child drop object drop event dot on server event colon connect function player. And so we'll also pass the object to drop, or actually we'll pass object name, we'll call it. And so in each of these labels we'll insert a string value. So the string value, and then we'll just say resource name. Copy and paste this into each label. And so now I can put stone here, wood here, and metal here. We'll basically use this to pass as the parameter for our object name. So player dot inventory. I'll do open close bracket object name dot value minus equals 1. And we'll actually also take all of our objects and duplicate them, and we're going to want to put them in replicated storage because we're going to replicate them into the workspace. So we'll actually make 2 folders, one for objects, which we could put these inside of, and the other will be for events, which we just made our only event we're going to be needing. So we'll do replicated storage dot events colon find first child drop object. And so local object to drop equals replicated storage dot objects open close bracket. And we'll do object name. And we'll do colon clone. And what colon clone will do is it'll make a copy of that object that we can use. Object to drop dot name will to be safe. In fact, we don't even need to set the name. So object to drop dot position will equal player dot character dot humanoid root part dot look, I think it's dot c frame dot look vector times 3 or 2.5 will do. Object to drop dot parent equals workspace. And so now all we got to do is get replicated storage. So local replicated storage equals game colon get service replicated storage. Local drop event equals replicated storage dot events colon find first child drop event. And so now what we could do is make some variables. In fact, yeah, we'll just make some variables for local wood label, local stone label, local metal label. This local wood label equals inventory menu dot wood label equals inventory menu dot stone label, and then inventory menu dot metal label. And so what we'll do is wood label dot mouse button to click colon connect function drop event. And we'll also make a local drop cooldown set equal to false. So if drop cooldown equals false, then drop event colon fire server. And then we'll do wood label dot resource name dot value. We'll also set the drop cooldown to true. Wait 0.5. Set the drop cooldown to false. And then we'll do the same for each label. So stone label, do the same for the metal label. And now let's test this to make sure that it's going to work. Mouse button to click is not a valid member. So one thing that we could do is whenever we aren't sure about events that are a member of an object is we can go to view, and there's this thing called the object browser. It'll display all the objects inside of Roblox Studio and all the events and functions inside of them. So here we're going to want to look for, because we use text label, we're going to want to look for the text label object, which is right here. And then our events that we can use is aha. I think I know why we cannot use them. And the issue might be because they are text labels rather than text buttons. So I will go ahead and change that real quick. Okay, so I have the GUI fixed. I have my text buttons here. If you have a custom image you'd like to use for your display in your inventory, you can interchangeably use an image button instead of text button and sub your images in. For now, I just have the text buttons. I have selectable, set false on them. I don't think that will, or selected. Selectable. I don't think it'll matter. Because the code will still function right. So yeah, let's test it to see if everything goes in the right position. So we collect our materials and we right click on them, and it doesn't really spawn them in front of us. So let's check our code. I see what it is. So we don't want to set it to our look vector because that might not always be in front of us. we'll set it to our player.character.humanoid root part dot position plus player.character dot humanoid root part dot cframe dot look vector. Instead of just setting it to the look vector, like multiplied by 2.5, we'll just set it to the position plus the look vector. So let's do that now and see how that works. And then there we go. Well, almost. The only thing is the wood, which I am confused about. Everything else is working fine though. But yeah, that's really all I have for part 1, that is. We can grab our resources, we can open our inventory, and we can drop them right in front of us. Still not sure about why the wood is acting like that, but let's just grab our... Whoops, well, the stone is going off, but we can grab our resources and drop them right in front of us for the most part. And so that's really all I have planned for part 1. In part 2, we might be focusing more on a data store oriented system where you could save your data. So say you get some wood, then you want to leave the game, and we'll have it so where those resources will save. So next time you join the game, you'll have everything and you could get back up and running and started, so you don't have to have a fresh start every time you're joining. What we established today was just a simple inventory system that we can use. And then we'll get the data store. Then we can actually get some survival mechanics, like some tree chopping and stone and iron mining, so we can actually spawn these in the game so we can collect them. So yeah, that'll be it for the tutorial. If there's some good positive feedback and you guys want to see more of this, like if the video does pretty well compared to how it normally does on my channel, then I will make another part in the series and continue it on. Otherwise, I'll just continue with what I normally put out on the channel, tutorial-wise. So yeah, that's it for the video.